So welcome to Honors Algebra 2. Honors Algebra 2. Yes, it's going to be awesome. It really is. And we are going to spend all of first semester talking about this word, function. Do you know what a function is? All a function is a relationship, right? It's a relationship between input and output. We put something in and we get something out. And that's kind of what our whole class is going to really be about, right? You put in effort and you get out results, right? So, and that goes with everything in life. There's an input and an output. And it's what we call a dependent relationship. In other words, the output depends on the input, right? What you input has an effect on what the output is. So the main thing about a function that you're going to remember from previous math classes is that the x value does not repeat. And that's kind of tricky at first, but we're just going to go with it, right? That's the definition. So functions can be represented in many ways. First is it a set of ordered pairs. So we look here, we see this set of ordered pairs. We're like, okay, got it. Then we could also take that set of ordered pairs and represent it in a table where we have an x column and a y column, and we've seen this before, right? A mapping is the exact same thing, just taking the table and using the words input and output. But the main ways that we're going to see an function play out is with an equation or a graph. So the equation is really what ties together the input and the output. So if you look at these ordered pairs here, there's a relationship between them. If I take the x coordinate and triple it and then add 1, do you agree that I get the y coordinate? 2 times 3 is 6 plus 1 is 7. 1 times 3 is 3 plus 1 is 4, etc. So the equation is really what holds it all together. And when things are a function, as all lines are, we're going to use this notation that stands for f of x. F of x is equal to 3x plus 1. And we'll go over this more, but I'm sure you remember how to graph a line where you graph the y-intercept, right, of 1, and then use the slope of 3, up 1, over 1. And the graph is another representation of the function. We can tell if we're looking at equations if they're functions if they use our f of x notation. And we can tell if we're looking at graphs if they're a function as if they pass the vertical line test, meaning only one, like every vertical line can only cross the graph once. That's basically the same thing as saying that the x values do not repeat. So that's just a little intro to functions, and then we're going to bring up two words that you already know, domain and range, right? Domain is the x values, or the input, and then range is the y values, or the output. And I remember that because it's alphabetical. X comes before y in the alphabet, D comes before R in the alphabet. So if you ever get confused, that's a good way to remember it. So now we're going to look at graphs and like mappings and kind of tell the domain and the range. So if it's given to us in a mapping, it's a little bit easy because the input is in the input bubble. Input is the domain, 3, -1, 2, 4. You can just list them out. You can put these funky little brackets, or you could just list them. And then the output is in the output bracket, which is 2 and 3 and 4. And maybe I'll add the brackets. Then it'll say, is this a function? In other words, are all the x's leading to only one y? Yes. Now you might say, well, didn't these both go to 4? They did, but the x value never repeated, so we're good. If you look at the next one, now the input is -2, 1, and 4. And then the output here is -4, 1, 2, 3. Is this one a function? Well, I notice here the double arrow coming off the 1. So that is telling me that the 1 repeats, therefore it is not a function. Now we're going to talk about graphs. And so graphs can be one of two ways. They can be kind of just dots, and this one is just dots. So when it's just dots, all we're doing is listing the coordinates of those dots. So I could, if I wanted to, I could make a little table for these ordered pairs and say, okay, this ordered pair looks like what? -2, -2, -2, -2, and then -2, 2, and then -1, 1, and then 1, 2, 3, 1. I don't have to do that. That's like optional, right? But sometimes that helps people get the domain of -2, -1, and 3. Did I have to say the -2 twice? Up to me. I could or I couldn't. I just didn't. My range is my y values, which has 4, -2, 2. Oh, actually the 1 repeats as well, so I can just write that one time. Funky brackets. Is this a function? Well, now we're going to say that vertical line test, right? Does a vertical line cross the function, and the function is just those dots, more than once? It does. So vertical line test is really showing me this part of the graph, that I have 2 -2's, that the x is repeating, so therefore it is not a function. So that's just dots. Now we're going to do actual graphs. And so when we're doing actual graphs, we're going to do this swiping. And this is hard for me to represent on here, but I'm saying to swipe your pen like kind of up and down, like make like a vertical line, and kind of picture that vertical line moving over the graph, and would that vertical line, like, when would it touch the graph? And remember, this graph had arrows, so that vertical line is going to touch the graph everywhere, or what we say is all real numbers. Right? Assuming that it just like kind of keeps on going up and down. If I want to do the range, now I'm going to take a horizontal line and picture swiping that up and down. Like, where is that hitting my graph? Well, it doesn't really start to hit my graph until right here, right? It's hard to represent there. So let me go back. I'm going to erase this again. So the domain was all real numbers, The range really starts hitting the graph here, which is at a y coordinate of -3. And then it's going to keep hitting it, all the way up to a graph of 3 on the y-axis. And it hit it everywhere in between. So we say the range is between -3 and 3. And this is a function. A vertical line only touched the graph one time. We'll try it here again with this oval, right? And so what I notice about the oval, it looks like an x value there of -4 and an x value of 4. If I have a vertical line that I'm swiping across this graph, it's not going to start hitting it till -4, and then it's going to stop hitting it at +4. So the domain, or all the x values on this oval, fall between -4 and 4. It's another way to think of it. All the x values on that oval fall between -4 and 4. And all the y values fall between -3 and 3. All the x values are between -4 and 4. All the y values are between -3 and 3. And we do these inequalities because of the infinite number of points. It's not just dots, right? It's infinite number of points in between. Is this one a function? Well, does it pass the vertical line test? Does a vertical line hit the graph more than once? A vertical line does hit the graph more than once, so therefore it's not a function because the x value repeats. Last one, and we know this is tricky, right? This is like the trickiest part, but you will be using this all semester, and we will get used to the fact that the x coordinates here are all positive. They are all bigger than 0. All these x coordinates here are bigger than 0. If I look at the y coordinates, the y coordinates are really going to be, it's going to touch it forever because this graph keeps going forever. So the range is all real numbers. Is this a function? Does a vertical line cross the graph more than once? Yes, it does. Therefore, it is not a function. So I understand the swiping is the hardest part of this first lesson, and it feels a little abrupt, but we will keep doing it and doing it all semester long. So it's going to be something that we will catch on to quickly if we haven't already. Here's the last thing. The last thing is evaluating functions. You've done this before, where you would say, well, if f of x, if the function says double and add 1, and I want to know what's f of 5, you're going to replace x with 5. So you're going to double 5 and add 1. If I double 5, that's 10. If I add 1, that's 11. If I take an f value of -3 and plug that in, right? So essentially what I'm doing is plugging it in for x, right? Taking this -3 and replacing the x with -3. 2 times -3 is -6 plus 1, -5. If I take a letter like a y and plug it in, 2 times y plus 1. Double it and add 1. The next one changes, right? So now it says g of x, it changes to the g function. So g of x is x squared. So it's telling me to square whatever I give you. Well, if I give you a 10, if I square 10, isn't that 100? What if I square -6? -6 times -6, right, is positive 36. What if I square 2y? You're right, 4y squared. 4y squared. So the letter tells me which rule to plug the number into. So the f of x, I plugged into the f function. The purple g of x, I plugged into the g function. Now I have h of x, but h of x isn't represented with an equation. It's represented with a set of ordered pairs. So remember, ordered pairs go x comma y. So if I say h of -5, what it's saying is what's the partner of -5? If -5 is the input, what is the output 2? If 0 is the input, what is the partner output? -1. It's basically just asking for the y coordinate. Phew, okay, so that's it. And this is just a little preview here at the bottom of what we're going to study this semester. So you see the word over and over again, function, 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 function. We're doing all different functions. We're going to start with a function you know, linear functions, straight lines. You've studied straight lines a lot, and so that's going to be a nice place as a jumping off point to review linear functions. What about quadratic functions? Do you remember what the graph of quadratic functions looks like? You're right, it's a parabola. You've studied that before. We're going to learn that again. Parabola. Cubic functions, you may or may not remember. I'm going to show you a cubic function kind of goes what we call up the hill. So let's talk about cubic functions. Rational functions, and you don't need to know any of these yet. This is just a little preview of what each graph looks like. The rational function graph is kind of a crazy looking one. It's kind of two pieces put together. Radicals, like sideways little swoop here, radical functions. Exponential functions, you might remember those. I think you did exponential functions last year. Anyone remember exponential functions? The graph goes up, right, exponentially. And then a new one for you will be log functions when we get to there. So every time we learn a new function, it's going to have a new graph and a new equation, but we're still going to have the domain of that function, the range of that function, evaluating that function. Some of these things we introduced here, we will do for each and every function. This is going to take us the whole semester. And so we don't have to know it all now, obviously, but by the end of the semester, we'll be able to look back on all these functions. All right, thanks for listening to our intro of functions.